Hi guys, so we're looking at section 5.2 today, and this is where we will discuss how to calculate the mean, variance, and standard deviation for a probability distribution, okay? So the idea is, of course, since we're looking at probability distribution, our calculations for mean, variance, and standard deviation is going to be very different if you were just calculating for samples, right? So in chapter 3, when we were talking about calculating the mean for a sample or population, we were looking at these two formulas over here, right? Basically where you added all your values and divided by the total number of values you have. Now think about this. If we were trying to compute what would be the mean number of spots that would show up on the top of a die when it is rolled, right? Are you going to have one spot, two spots, or six spots? And how many times would you have to roll the die? So if you tried doing this for 10 rolls, 100 rolls, 200 rolls, each one of them would be just a sample, right? Which would be approximating your mean. But then basically, if you wanted to find close to an accurate answer, you would probably have to roll it an infinite number of times, which is not possible. So, these formulas really would not work in this case since you are talking about for each spot, for each die, how many spots you would get, what would be your mean number. So really that method doesn't work for us. So just kind of considering another example so we can explain this concept a little bit better. Let's say we are tossing two coins, okay, repeatedly over and over again, and we record the number of heads. So of course, when you're talking about number of heads, you can have 0 heads, 1 head, or 2 heads, right? When you're talking about rolling two coins. So now let's say we wanted to find out what will be the mean number of heads. So how many heads will we get as our mean number, right? So in this case, since you have a total of 4 outcomes in your sample space, we would say the possibility of each outcome is 1/4, right? Or the probability of each outcome would be 1/4. So they are saying now in the long run, you would expect 2 heads to occur approximately 1/4 of the time. You would get 1 head 1/2 of the time, because 1 head could come from 2 outcomes, right? So that would be 2 out of 4, or basically 1/2, counting both of those. Or you could get no heads, of course, that is when you got both tails, right? Which would also occur 1/4 of the time. So what you have to do to find your average, your mean, we would say, okay, getting 2 heads multiplied by its probability of 1/4, getting 1 head multiplied by its probability of 1/2, and getting 0 heads or no heads multiplied by its probability of 1/4. So if you go ahead and do all these multiplications and then the additions, that actually will end up giving you 1 as your answer. So we are saying, on an average, if you were to toss 2 coins as many times as you can, or basically an infinite number of times, your average number of heads would be 1. So we are saying the more you would toss these coins, the average you would get on both your coins is that one of them would be a head. So as you can see, when we are trying to find the mean for a probability distribution, you actually take each of your possible outcomes and multiply it by their corresponding probability, and then find the sum of those products. So you're literally taking each outcome, multiplying by its probability, each outcome multiplied by its probability, and then you add all of them together. So this is actually your formula for finding the mean for a probability distribution. And again, you will notice here we're using the Greek letter mu over here to represent our mean, okay? So this is just talking about n possibilities, just depending on how many total possibilities you have, okay? Now let's talk about the rounding rule before we get into examples. So basically we are saying for the mean, variance, and standard deviation, your rounding rule is basically going to be, it should be rounded to 1 more decimal place than what your outcome x will have. So if your outcome x is whole numbers, then your mean, variance, and standard deviation has to be 1 decimal place. So in that same way, if your outcome has 1 decimal place, then your mean, variance, and standard deviation, you will have to go to 2 decimal places, and so on and so forth, okay? Now, if you leave your calculations as fractions, then just make sure you always write your fractions in lowest terms, okay? So let's talk about this first example here. We're talking about finding the mean number of spots when a die is tossed. So again, your outcomes for a die would be 1, 2, 3, 4, 5, or 6, right? And we know from our theoretical or classical probability that each outcome will have a probability of 1/6. So you're going to take each of your outcomes, multiply by their probability, right? Add all of those products together, and you're basically getting 21/6 or 3.5 or 3.5 as your mean number. So basically we are saying if you were to toss your die as many times as possible, or basically that idea of infinite number of times, if you're tossing your die, the idea is your theoretical mean will be at 3.5. Now, of course, our die does not have the number 3.5, right? You're either going to be 3 or the number 4, but again, we're saying theoretically, your average is going to be 3.5. So they're saying the reason why this formula gives us a theoretical mean is that in the long run, we know each outcome would occur approximately 1/6 of the time, right? So if we take our outcome 1, which is you would get 1 spot on your die, then of course you would say that would occur 1/6 of the time. Outcome 2 would occur 1/6 of the time. And so multiplying by your outcome by its probability and finding the sum basically gives you that theoretical mean, okay? Now, another example here is talking about a family with 4 children, and we want to know what the mean number of girls will be, basically, in this family. So, of course, the first thing you have to do is find your sample space, and we had actually done this example in the last chapter, but you will have 16 outcomes here. So basically, your number of girls can be 0, which means all of them would be boys, right? So that's going to be an outcome of 1 out of 16. You could have exactly 1 girl out of those 4 kids, so that would be 1, 2, 3, and 4, right? So 4 out of 16 outcomes, you would have only 1 girl, and you can have 2 being girls, so that would be 1, 2, 3, 4, 5, and 6, right? So you're going to have 6 out of 16 outcomes where you would have exactly 2 girls out of the 4 children. And then, of course, we can have 3 out of the 4 of the children being girls, so that would be 1, 2, 3, and 4, so that would be 4 out of 16. And then there's only 1 out of 16 chance that all 4 of those kids would be girls, right? So of course then we go ahead and create our probability distribution like we have here, and then again multiply each outcome by its probability, and that is giving us a mean value of 2. So we are saying that the mean number of girls in this family will end up being 2. So you can see it's a pretty straightforward calculation, right? Not too bad. So we have looked at this example back in section 2.1, so we're just kind of revisiting here. They're saying if 3 coins are tossed, what are the mean number of heads that will occur? So you can get no heads, right? So that would be 0 heads with a probability of 1/8. You can get exactly one head, yeah, and that would be 3 different outcomes, so that would be 3 out of 8. You can get exactly 2 heads, which would again be 3 different outcomes, so that would be 3 out of 8. And then there's only one possibility, one outcome, where all 3 of them would be heads, and that would be 1/8. So So again, same thing, multiply your outcome by its probability, and you get a total of, or a sum, yeah, a total of 12 over 8, or 1/2, or 1.5. Now again, technically you cannot get 1.5 heads, but again, like we were talking before, this is going to be your theoretical or long run average value over here, okay? Same example from our section 5.1 where we had talked about the convenience store selling different packages of batteries. So again, we're bringing that information here. So we've got our frequency table, and then we're converting that into a probability distribution over here. So again, multiplying each outcome by its probability ends up giving us 4.56. So we're saying basically the average or mean number of batteries that this convenience store is selling is about 4.56 batteries, right, over the weekend. So that was our calculation for mean, for probability distributions. Now let's look at how we can calculate our variance and standard deviation. So as you can imagine, just talking about the mean is not going to be enough, because again, we need to kind of know how far our probability distribution is spread out, and that is where the idea of variance and standard deviation come in. Again, these formulas that we have looked at in chapter 3 are not going to work, so we're actually going to need a new formula for our probability distribution. Now this formula that you're seeing right over here is actually the longer way of doing it, because here you're taking your outcome, subtracting the mean from it, then squaring that value, and then multiplying with your probability distribution, and doing this for each individual outcome separately. So we're actually not using this formula, but we're going to be using this one here, which is a shortcut method. It's simplified and it still gives you the same result instead of going through the longer way here. So what we do here is we take each outcome, square it individually, then multiply it with its probability, and then when you get that answer, you go ahead and add all of them for your outcomes, and then finally when you have that total sum, then you just subtract from the square of your mean, and you're going to end up getting your variance. And then of course, anytime you take a square root on the variance, you get your standard deviation. Okay, so again, just something to keep in mind, both your variance and standard deviation cannot be negative values. Okay, so we're going back to our example of rolling a single die. So of course our outcomes are going from 1 through 6. We know each probability is going to be 1/6. So go ahead and multiply the outcome with the probability, and we get a mean of 3.5, right? 3.5 here. So once you have that mean, right, so now that we have our mean, we are ready to calculate our variance and standard deviation. So the first thing you're going to do is you're going to square each outcome individually, which means we are taking the square of each of our outcomes here, right? Then multiply with their probability. So 1 squared times 1/6, 2 squared times 1/6, 3 squared times 1/6. You do it for all of them. Add each one of them together. And then as you can see, we're putting these in parentheses. And then from that total, we are subtracting our mu squared, our mean squared, which is 3.5 squared. And that's actually giving you a variance of 2.917. And when you take the square root on 2.917, you're getting your approximate standard deviation. And in this case, we're saying your standard deviation for rolling a die is going to be 1.708. Okay, so that's your variance, and then this here is your standard deviation. Okay, so just continuing with another example here, we're talking about a box containing 5 total balls, and they're saying 2 of those balls are numbered 3, 1 is numbered 4, and 2 of the balls are numbered 5. So 2, 1, and 2 of course adds up to a total of your 5 balls. So they're saying the balls are mixed and one is selected at random. After you select the ball, you record the number that's on the ball, put it back, replace it, and you continue this experiment many times. And then, of course, we're trying to find out what the variance and standard deviation of the number of balls will be, right? So they're telling us the balls are numbered 3, 4, and 5. There's 2 of the balls that are numbered 3. 1 ball is numbered 4, and 2 are numbered 5, right? And that's from a total of 5. So that's how you're calculating your probability over here. So the first thing, of course, we need to do is find our average. So to find our average, you just take the outcome, multiply by its probability, and we're getting a mean of 4. So we are saying that on an average, you would actually be seeing the number 4 ball on that average, right? Now to calculate our variance, we square. So you take the square of the outcome, multiply by the probability, square of the outcome, multiply by the probability, and then this sum, you're going to add these guys together and then subtract the 4 squared, which was your mean, and that gives us a variance, and this should actually be variance. So that should be sigma squared over here. There's a little typo there, okay? So that comes out to be 4/5 or 0.8. And when you take a square root on that value, you're going to get your standard deviation of 0.894. So this was just kind of doing our example like we would normally do, but they are showing you that you can actually also use a table to do the same calculation. So you take your outcome and your probability, and you can set them up as vertical columns. So when we multiply the outcomes times the probability, we get our x times px. So this is going to be our calculation for the mean. So this here is your mean, and then when you take x squared times the probability, this will actually give you the first part for your variance calculation. So from this 16.8, you are then going to subtract the mean of 4. So you can see that calculation over here, and of course remember that's got to be 4 squared. So that's the calculation they're showing you right here, and then going through that calculation gives you a variance of 0.8, and then square root of 0.8 gives you 0.894, which is going to be your standard deviation, right? So you can also set it up as a table, and it might actually visually be better to set it up as a table, so that way you know your calculations are going to be accurate. Okay guys, so our next example here is talking about a radio show over here. So we've got a talk radio station that has 4 telephone lines. So they're saying if the host is unable to talk, that is during a commercial or something, or he or she is already talking to a person, then the other callers are placed on hold. So when all lines are in use, people who are trying to call in will end up getting a busy signal, right? So the idea here is you can have a probability for 0, 1, 2, 3, or 4 people will get through, right? Because since they have 4 telephone lines, you can have 4 people at the maximum coming through those lines, right? So based on that outcome, you've got your probability distribution here. So 0 callers get through, 1 caller gets through, 2 callers get through, 3 callers get through, or 4 callers get through. So you've got your probability distribution. Now they are saying, should this station have considered getting more telephone lines installed, which means are a lot of people getting placed on hold or not, and based on that, should they get more telephone lines installed? So let's take a look at what kind of numbers we have here. So we start by calculating our mean. So again, that's 0 outcome multiplied by 0.18, 1 times 0.34, 2 times 0.23, and going all the way to our 4 callers over here, which is giving you a mean of 1.589. So we are saying 1.5 people are still getting through, right? Okay, now let's talk about the spread. So with variation, you're going to do your outcome squared, 0 squared times 0.18, 1 squared times 0.34, again going all the way to our fourth color, and then taking a total of that sum and subtracting our mean squared, so 1.59 squared. Going through those calculations is giving us a variance of 1.262. Taking a square root on that number gives you a standard deviation of 1.123. So what do these numbers exactly mean? So we're saying the mean number of people calling at any one time is 1.59, right? So 1.59 callers are definitely getting through because they have 4 phone lines. Now we are saying the standard deviation is 1.123. So most callers would be accommodated by those 4 lines, because think about it. You have 1.59 callers making it through. And if we did 2 standard deviations using the 1.123, that is still coming out to be 3.836, which is approximately 4 callers. So you are still getting 75% of your callers are still getting through, because that's up to number 4, right? Which means all 4 lines can be used. So there are very, very few callers who are actually getting a busy signal. And since you're not getting a whole lot of people who are getting put on hold, you don't need to install more phone lines. And as you can see, this is actually a calculation that's coming from your Chebyshev's theorem, because we cannot assume this example is normally distributed. So that's why we cannot use normal or empirical distribution here. We have to use Chebyshev's theorem. Okay, so this was just looking at the examples in our handout. Now let's look through some examples from our textbook. Okay, so from our textbook, we're going to be looking at example 4 over here. So this one is talking about the probabilities that a player will get 5 to 10 questions right on a trivia quiz are shown below, and they're asking us to find the mean, variance, and standard deviation. Right, so they're saying you can get 5, 6, 7, 8, 9, or 10 questions correct, and what's the probability of that? Okay, so let's go ahead and take a look at how we can calculate our mean, variance, and standard deviation here, right? So you can of course leave it the way it is, or remember how we were talking about you can write these in columns. So I'm actually going to go ahead and rewrite these in a table, so you can kind of see what this looks like. Okay, so you can kind of see I've gone ahead and drawn our little table. So when we're talking about finding the mean, you're basically just multiplying your outcome by its probability, right? So let's go ahead and take a look at those numbers. So you would multiply 5 with 0.05, right, which would end up giving you 0.25 over here. Then we would multiply 6 with its probability, which is 0.2, and of course that would give you 1.20. You can write it 1 decimal place, 2 decimal place, it doesn't matter. If you did the same thing, 7 times 0.4, you would have 2.8, right? So you can go ahead and complete that table, and then you can come back. Okay, so once you have your multiplication done, then all you need to do is go ahead and add these numbers, right? So what do you think that total will come out to be? Okay, so this total comes out to be 7.4, which will be the summation of that column, which basically represents the mean of our data value. So that mean is going to come out to be 7.4, okay? Now to calculate our variance, we're going to need to complete this last column. So this is basically where you would be taking the square of the data values and then multiplying it by the probability. So square of each of these data values. So I'm just going to show you basically what that will look like, right? So 9 squared times 0.15, 10 squared times 0.1. So you'll go ahead and do these calculations individually, and then of course we'll take the total of that column. So let's go ahead and find out what these individual problems could be. And again, if you're comfortable, you can try typing it all in your calculator at one time, but again, I would recommend using parentheses. So around each of these individual calculations, I'd go ahead and put a square. So this would be, of course, 5 times 5, or 5 squared, and then you would multiply 25 with 0.05, right? Which would then end up giving you 1.25. So of course we need to do this for each of these values. So go ahead and do those calculations, and then you can come back and see what that answer is. Okay. So again, you've got your individual totals, and then you can go ahead and sum all of these up together. So that would be the sum of this column, and then of course that's going to be 10 plus your 12.15, and then let's see, 6.4, 19.6, 7.2, and then of course 1.25. So if you go ahead and add all of those up together, you get 56.6. So now what's going to happen is, in your variance calculation, we take this total here and then subtract it from our mean squared, which means we are going to take our 56.6 and subtract our 7.4 squared from it. So you can go ahead and do that calculation and see what that variance comes out to be. Okay, so when you go ahead and do this little variance calculation, you will see that you end up getting 1.84, and then of course using our rounding rules, this will actually just come out to be 1.8. So now that you have your variance, then for the standard deviation, of course, you just take a square root on your variance. So I'm actually going to take a square root on 1.84, and then that will give us our value for our variance over here. Okay, so this is my rounded answer, 1.36, which will of course again round up to 1.4. So we've got our mean as 7.4, our variance as 1.8, and then our standard deviation as 1.4, and this was of course for our problem number 4. So you can kind of see what those calculations look like for probability distribution. Now I actually had one more example I wanted to make sure you guys were comfortable working through, and this one is number 6 over here. So this is talking about the county highway department recorded the following probabilities for the number of accidents per day on a certain freeway for 1 month, right? So they're saying the number of accidents per day and their corresponding probabilities are shown, and again we're finding the mean, variance, and standard deviation. So 0 accidents, 1, 2, 3, up to 4 accidents, right, on a per day basis for 1 month. They've got this probability distribution here, so I've got this one copied over here already. Okay, so again you can do this just by leaving it as it is, or again if you wanted to put this in table form, you can definitely do that. Okay, so of course again just putting it in our table format, when you're trying to calculate the probability of 0 times 0.4, 0 times anything is going to be 0. 1 times 0.2 of course is going to be 0.2, and then 2 times 0.2 of course will give you 0.4, 0.3, and 0.4 over here, right? And when we go ahead and add all of these, we'll get our total for the mean. So when you add this 0.4, 0.4 is 0.8, that's 1, you should get a total of 1.3 over here, which would be the summation of our x times p of x column, which of course is our mean. So the mean comes out to be a total of 1.3. Now for your variance again, like I showed you in the previous example, square the outcome, multiply by the probability, so 0 squared times 0.4, 1 squared times 0.2, 2 squared is also that should be multiplied by 0.2, 3 squared times 0.1, and then of course 4 squared times 0.1, right? So 0 squared again is 0 times anything, which will be 0. 1 times 0.2 of course will be 0.2. 2 squared is of course 4. 4 times 0.2 will be 0.8. 3 squared is 9. 9 times 0.1 would be 0.9. And then 4 squared is 16. 16 times 0.1 will actually give us 1.6. So we can again go ahead and add up this column for x squared times p of x. And let's see what that total comes out to be. Okay, so this total will come out to be 3.5. So now we can calculate our variance, which is going to be the sum of this column. And then from that, we will subtract our mu squared. So that's 3.5 minus 1.3 squared. So let's go ahead and see what that comes out to be. Okay, so when you go through that calculation, you get 1.81, or again, using our rounding rules, it will be 1.8. And then standard deviation would be the square root of 1.81. And that will come out to be, let's see, approximately. Okay, so when you take square root of 1.81, you get 1.34 and then a bunch of numbers after that. So just following our rounding rule, it comes out to be 1.3. And so now you can see we have a mean of 1.3, variance of 1.8, and then standard deviation of 1.3. So again, just another example to show you how you can calculate your mean, variance, and standard deviation for a probability distribution. Okay, so again, I will have more examples for us to work through in class, but hopefully this gives you a fairly good idea of how we are going to be working through our probability distribution calculations. Okay, so again, if you have any questions, please let me know, and I will see you guys in class. Have a wonderful day, and be careful. Okay, bye-bye.